so we are now on our second law, no, of the gas law, no, which is the Charles law. So this law states that volume of a fixed mass of a gas is directly proportional to its absolute temperature. So meaning, we're gonna be using volume and so Charles law, no, of course from the name of the law, no, so si Jacques Charles, no, yung ating proponent. So he was a French-born balloonist. So he really studied balloon, no, in his time. Who flew the first hydrogen balloon in 1783. So Charles did an experiment where he did an experiment where he filled 5 balloons of the same volume with different gases. He then raised the temperature of the balloon to 80 degrees Celsius. So it is not constant, no, na temperature. And notice that they all increase in volume. So when a gas is heated, its molecules gain kinetic energy and they actually move faster. So these faster molecules hit the walls of their container more frequently, no, because of the temperature, and with more force, no, since they are moving to the walls of the container. So if the pressure must remain constant, the container must expand to allow more space for the particles, which leads to increasing volume. So ito yung thought sa Charles law. Okay. Next, so as what I have said on the previous slide, at constant pressure, no, so this time will not be minding pressure, no, kasi on this situation, pressure is constant. The volume of fixed quantity of a gas is directly proportional to the absolute temperature. So this means that provided the pressure in the gas remains constant, the volume will increase proportionally to the absolute temperature. That is, the volume of a gas will double if the absolute temperature, not the temperature in the Celsius or Fahrenheit scale, it is in Kelvin, no, is also doubled. So ito yung formula, no, ng ating Charles law. So yeah, as what you notice, walang pressure dyan, no, sa ating formula. So V1 divided by T1 is equal to V2 divided by T2. So ito yung ating magiging formula. Okay, so we are now on the part where we're gonna what do you call this? We're gonna rearrange, no, the formula. Okay, so and here this is our formula again: V1 divided by T1, V2 divided by T2. So if we are looking for V1, so we are looking for this, simple lang yung gagawin natin. We have to transfer yung kasama niya on the other side, which is the T1. So this T1 right here will transfer on the other side, and since this is a denominator, it will be transferred on the other side as a numerator, just like this one. Okay? So as what you notice, V1 is equal to V2, and yung T1 na nandito, gi-transfer natin sa taas. Okay? T1, transfer dito sa katabi ng V2. And of course, remain lang yung T2 na nasa baba. If V2 naman, as what you notice, V2 yung hinahanap, so yung kasama niya, nilipat natin sa kabilang side. So V1, T2, magkasama na sila, and then ang T1 na nasa denominator, nag-remain lang siya. If ever T1 naman yung hinahanap, okay, if ever T1, no, so dito medyo baka malito kayo, but just listen lang. If T1 yung hinahanap, we have to transfer muna yung mga denominator natin sa numerator on the other side. So just like this one, T1 will be transferred sa kabilang side, which magkatabi na sila ni V2. Yung T2 naman natin, transfer din natin sa kabilang side sa numerator, magkatabi na sila ni V1, just like this one. Okay? So, with this, simple na lang yung pag-transfer or pag-determine natin ang formula na gagamitin natin. So, T1, just like sa Boyle's Law, yung, di ba, pag may katabi, itong V2 na to, ilalagay natin sa baba. Just like this one. So, T1 is equal to V1 times T2 over V2. Okay? Same yung gagawin na step, no, sa if T2 naman yung hahanapin. Okay? And since alam niyo na kung paano gawin to, proceed na lang ako. So, we have T2 right here. Ang katabi niya is V1. So, simple yung gagawin. Ibababa lang natin siya. Okay? Okay, so we're gonna be proceeding with our sample problem number 1 since na-determine na natin yung ating formula. So, here, okay, so a gas sample is observed to occupy 12 liters. So, we have our volume there under a pressure of 101.325 kilopascals, also 1 atm yung equivalent niya, at 27 degrees Celsius. What will be the volume of the gas if it is heated to 57 degrees Celsius under the same pressure? So, as what you notice, the same pressure daw. So, meaning, 101.325 kilopascal or 1 atm pa rin yung pressure. No? So, meaning, constant yung pressure and dun yung malalaman na gagamitin natin yung Charles Law. Okay, so we have our given here. The first one is ating V1, which is, na-mention siya, no? 12 liters. Ang ating P1 naman, no, though hindi na siya necessary ilagay, pero since na-mention siya dyan, so ilalagay lang natin yung P1 natin. Next, ang ating temperature 1 naman, no, is 27 degree Celsius. Take note na we have to convert it to Kelvin kasi nga may absolute zero ang Kelvin. Next, ang P2 naman natin, no? Kasi nakalagay dyan, same pressure. So, of course, same pa rin, 101.325 kilopascals. And, of course, ang hinahanap natin, no, is ang ating V2, no? So, since, if you, like, look at the question, wala ka naman makikitang ibang liters dyan. And nasa question din siya, what will be the volume of the gas? Okay, so, meaning unknown ng ating V2. And of course, ang ating T2 is 57 degrees Celsius. Add tayo ng 273. And we're gonna have 330 Kelvin. So, for the solution, so since the pressure is constant, no, so Charles Law yung gagamitin natin. So again, ito yung formula, V1 divided by T1 is equal to V2 divided by T2. Okay, so since V2 yung hinahanap natin, as what I have said sa previous na mga slides, ang T2 is transfer natin sa kabilang side, and since denominator siya, magiging numerator siya. And magiging ganito siya. V2, no? So, ito siya. V1, ang T2, i-transfer natin. And ang denominator is T1. So, same sa Boyle's Law, we're just gonna have to distribute yung given natin. So, ang V1 natin is 12 liters. Right here. Ang T2 naman natin is 330 Kelvin. Ang ating T1 naman is 300 Kelvin. So, of course, this one is, makancel ito, no? Itong units of Kelvin. So, i-multiply lang natin 12 times 330 divided by 300. And we'll get our V2, which is 13.2 liters. So, ganun lang kadali ang pag-solve sa ating Charles Law. Another problem, or sample problem number 2, to what temperature in degrees Celsius? So, take note kayo sa mga ganito na question, ha? Kasi minsan, gina-require nila ang certain unit, no, ng temperature ba yan or volume. Degrees Celsius must 1 liter of gas at 0 degrees Celsius be heated to expand its volume to 275 liters. So, first, identify muna natin yung given. So, you have our V1, no, na-mention dyan, 1 liter. Okay? Ang T1 naman natin, no? T1 natin is 0 degrees Celsius, so plus 273 is equal to 273 Kelvin. Ang V2 naman natin is 275 liters. Ang hinahanap is temperature in degrees Celsius. So, yun yung hinahanap natin, T2. Okay? So, yun. So, as what you notice, walang given dyan na tawag nito, walang given na pressure. So, no need na natin siya ilalagay. And this is an indication na we're gonna be using the Charles law. So, for the solution, again, pressure is constant and actually, hindi naman siya na-mention. So, we're gonna use this. So, again, since T2 yung hinahanap natin and denominator siya, ang gagawin lang natin is to transfer ang mga nasa denominator sa kabilang side to the numerator. So, ganun yung ginawa, diba, sa pag-determine or pag-rearrange ng formula. And then, we're gonna come up with this formula. So, again, gitransfer natin yung T2 sa V1, T1 sa V2. Okay? So, since T2 dito, T2 yung hinahanap natin, yung V1 is bababa. So, nandito na siya sa baba. Okay? So, distribute lang natin. V2 natin, no, is 2.75 liters. Yung T1 naman natin is 273 Kelvin. Ang V1 naman natin, no, is 1 liter. So, 275 liters times 273 Kelvin, no? So, this will be cancelled, divided by 1. And we'll get 750.75 Kelvin. Take note, the question states that to what temperature in Celsius. So, since Kelvin yung sagot natin, no, Kelvin yung sagot natin, i-convert natin siya ulit into Celsius. So, again, the formula in getting the Celsius, we have Kelvin minus 273. Di ba, vice versa lang sila. If, if yung, tawag nito, if yung, ang given naman natin is Celsius, no, mag-add lang tayo ng 273 para makuha natin yung Kelvin. Okay? So, it goes like this. So, again, in order for us to get the degree Celsius, Kelvin minus 273. So, since we have our 750.75 T2 na value in Kelvin, mag-minus lang tayo ng 273 and our final answer is 477.75 degrees Celsius. So, this is not the final answer but this one. Our T2 is 477.75 degrees Celsius. Kasi nga, again, to what temperature in degrees Celsius yung hinahanap. I hope you got that. Okay, so supposedly if face-to-face, no, yung klase natin, practice problem sana to, but we'll consider this as sample problem number 3. So here is the question. 600 ml of air is at 20 degrees Celsius. What is the volume at 60 degrees Celsius? So, ang given natin, we have our V1, no? So, obvious masyado ang V1 natin. 600 ml. Ang T1 naman natin, no, is 20 degrees Celsius and kailangan natin i-convert to Kelvin. So, mag-add lang tayo ng 273 and we'll get 293 Kelvin. And ang hinahanap, no, what is the volume? So, yun yung unknown natin. And ang ating T2 naman is 60 degrees Celsius. And of course, we'll have to add 273 in order for us to convert it to Kelvin. So, again, pressure is constant. Actually, hindi siya na-mention. Very short lang yung question. So, ito yung ating formula. So, again, paulit-ulit, itong nasa, anong tawag nito? Itong nasa baba ng ating unknown, no, is ilalagay lang natin sa kabilang side, which will become numerator. Okay? So, distribute lang natin yung amount or the amount, no, of each, the value, no, or given natin. So, V1 is 600, T2 is 333 Kelvin, T1 is 293 Kelvin. Okay? So, of course, makakancel itong Kelvin na sign. Okay? So, V2 will get 681.9 or 682 Kelvin. So for our sample problem number 4, no? So a gas occupies 900 ml at a temperature of 27 degrees Celsius. What is the volume at 132 degrees Celsius? So first natin identify, no, same, no, is given natin. So ang V1, no, obviously, nandito siya sa first part pa lang ng question, 900 ml. Ang T1 naman natin is 27 degrees Celsius. So mag-add tayo ng 273, we're gonna get 300 Kelvin. And of course, ang tinatanong or hinahanap is the volume. So that would be our unknown. Ang ating temperature 2 naman or T2 natin is 132 degrees Celsius. Mag-add tayo ng 273 and we'll get 405 Kelvin. So for our solution, V2 yung hinahanap. Okay? So since si V2 yung hinahanap, same, no, yung gagamitin natin na formula. Distribute lang natin yung ating mga values. So V1, 900 ml. T2 is 405 Kelvin. T1 naman is 300 Kelvin. So, cancel lang natin itong mga Kelvin na to. So, 900 times 405 divided by 300 and we'll get 1,215 ml. Okay? So, this is the value of our V2. So, for the practical applications naman ng Charles' Law, so a balloon that has been inflated inside a cool building expands when it is carried to a warmer area like the outdoors. So this is why we often see balloons just bursting even when nobody is near it. No? So if you have a party and then there's an exposure of sunlight, so there's a big possibility na mag-ano talaga siya, mag-pop. No? Kasi nga, the warmer the area, no, especially outdoor exposure sa sunlight, no, mag-expand yung ating balloon. Next is another application, no. The capacity of human lungs is reduced in colder weather. Okay, like pag nasa South and North Pole, no, na areas. This is why athletes who come from countries with warm climates like Philippines may find difficult to perform well in countries with severely cold weather due to difficulty in breathing. For the same reason, asthmatic people usually experience asthma attacks when there is a sudden change in temperature, no? So if ever sanay ka na wala kayong aircon and then eventually nag-aircon ka for like a couple of days, no? So eventually, and if you have an asthma, so mag-trigger talaga yan siya. Kasi nga, there is a change in temperature. Another one, so, ang Charles law daw, along with other gas laws, can explain the process of leavening or rising of bread and other baked goods during baking. Small packets of carbon dioxide gas produced by the action of yeast or leavening ingredients expand when heated. This causes the dough to rise or expand, which results in lighter finished baked goods. Last application ng Charles' Law. So, car combustion engines work by this principle, no, sa Charles' Law. The heat combustion of the fuel causes the combustion gases in the cylinder to expand, thereby pushing the piston, causing the crankshaft to turn. Okay? So, ito yung practical application ni Charles' Law.